Today we're going to do these linear inequalities, and I'm going to show you how to do it both graphically and numerically. So, let me get this up here. Graphically, what you're going to do is you're going to take y1 and type all this in exactly as it is, and this is y2, and type that in all exactly as it is. You will do no algebra to solve. You'll just put it in your graphing calculator. So press your y1 key, type it in exactly as it is, four parenthesis 1 minus x parenthesis plus 3x. Enter. And in y2 you'll put negative 2 times parenthesis x plus 1 close parenthesis. Enter. And then to make sure that we're on our standard window, negative 10 to 10, we're going to type zoom 6. So we see it intersecting up here, so we need to adjust our y's up a little higher. So press your window key and go down to your y max, and let's try 20. And hit your graph key. And we see the intersection quite clearly now. So we're going to hit our calc, which is above trace, so second trace, and we're going to calculate the intersection number 5. It's blinking on my first curve. You see your first curve up in the corner. Hit enter. It jumped to my second curve. It's blinking on my second curve. Hit enter. Then it says make a guess. So I'm going to move this spider up to where my guess should be. So that looks pretty good. Hit enter. And I get x equals negative 6. I'm solving for x, so I don't even write down the y. Okay, so let's go ahead and try another one. So we're going to press y equals. We're going to clear out what we have. And this will go in y1, and this will go in y2. So I'm going to go 1 divide 4 times parenthesis 12 x plus 16. And in y2, I'm going to put 10 minus 3 times parenthesis x minus 2 parenthesis. And again, I'm going to hit my graph key. And again, I see the intersection quite clearly, so second trace, the intersection, first curve, second curve, and I'm going to come down here to my guess and hit enter. And I got x equals 2. Now, that's graphical because we see it all right there. If I want to see it numerically, I'm just going to go to my table. So let's go to our table. And we want to look, where is y1 equivalent to y2? So as we look through our table, we see right here at 2, both y values are 10. So it is also x equals 2. So what would it look like if it was infinitely many solutions? This would say 7, 7, 10, 10, 7, 7, 16, 16. These would all be identical. Then it is all reals. If it was no solution, you'd look through and you would not find any pairs y's that are equal. Graphically, no solution should be parallel lines. Infinitely many solutions should be the same line. So graphically, it's going to look like just one line. All right. We're also going to do some critical thinking, which is our 5-step problem solving plan. So no matter what, when you are problem solving, make sure you always read the problem carefully first. Then go to the question and identify your variables. Then reread the problem and write an equation to every sentence. Go ahead, solve your equation, and then, just as important as the previous 4, go back and check that your answer makes reasonable sense. So here's our first problem. A car salesperson's base salary is $21,000. She earned a 5% commission on sales. How much must she sell to earn $65,000 total? So when I read the problem, I see she is to make $65,000 total. How much must she sell? That's what I'm looking for. So how about we call S her sales? If you are earning, that's an equal $65,000 total. So it's going to equal $65,000. Let's reread the first sentence. She has a base salary of $21,000. What does it mean to have a base salary of $21,000? That no matter what, you earn $21,000 for the year. Then she earned a 5% commission on sales. And a 5%, 5% is 0.05 is the decimal, on sales is times sales. Now we have an equation to solve. So we would, see if I can get a different color here. Subtract 21,000. 0.05S equals 44,000. Divide by 0.05. And S equals 880,000. Now, does it make sense that a car salesperson could earn $880,000 worth of cars? Yeah, you could easily sell that in a year. So she sold $880,000 worth of cars. Okay, let's try another one. A person is 66 inches tall and standing 15 feet from a streetlight. If the person casts a shadow 84 inches long, how tall is the streetlight? Well, in this case, I like to draw a picture. So here's a person, and they are 66 inches tall. This person stands 15 feet from a streetlight. As the streetlight shines down, it casts a shadow of the person. The shadow is 84 inches long. How tall is the streetlight? So there I've identified my variable. H is the streetlight's height. This bothers me that I have feet and I have inches. So let's turn this feet to inches. So 15 feet times 12 inches is 180 inches away. So do you see, let's see if I can get this one. That right here is a triangle. And then I have a second triangle right here. So I could set this up as big triangle to little triangle. So on the big triangle, I have height. On the little triangle, I have 66. On the big triangle, I have 84 plus 180, 264. On the little triangle, I have 84. So I have h times 84 equals 66 times 264. Divide by 84. H equals, so let's see, I got my calculator right here. 66 times 264 divided by 84 gives me 2093.14 inches. If I want to see if that's reasonable, I want to divide it by 12 so I can see my height. Oops. Actually, I'm off by a decimal because I put 666. So let's retype that. 66 times 264 divided by 84. 207.43 divided by 12. 17.3 feet tall. Does it make sense that a street lamp would be 17 feet tall? It seems it's reasonable. The street lamp is about 17 feet tall. Okay, let's try another one. A car travels 372 miles in 6 hours, traveling at 55 miles per hour and at 70 miles per hour. How long did the car travel for the part of the trip when traveling at 55 miles per hour? How long did the car travel at 55 miles per hour? I see this labeled miles per hour, so I automatically write miles per hour. Anytime you have a label that's a fraction, you want to multiply by your denominator, so I'd multiply by hours. This would then reduce out, so the result would be equals miles. And this creates a way for us to organize our information. I have two parts of the trip. I have the part at 55, and I have the part at 70. $372 miles in 6 hours. Is that at any particular part, or is it the total trip? It's the total trip, so I also need a total. So I have 372 miles total in 6 hours. 55 miles per hour, so that's 55. 70 miles per hour, so that's 70. How long at 55? H. I don't know that. So if this is H, this one we don't know, but the total is 6, how can I represent this in terms of H? Total minus H, so 6 minus H. This says to multiply, so this gives me 55H. This gives me 70 times 6 minus H. And right here, I end up with my equation. 55H plus 70 times 6 minus H equals 372. That's 55H plus 420 minus 70H equals 372. 55H minus 70H is 420 minus 15H equals 372. Subtract 420. Negative 15H equals negative 48. Divide by negative 15. H equals 3.2 hours. Does it seem reasonable that it would take us a little longer to travel a distance at 55 miles per hour than it would at 70? That seems very reasonable. And then I have just one more problem, and it's a work rate problem. A large pump can empty a swimming pool in 50 hours, and a small pump can empty the pool in 80 hours. How long does it take to empty the pool using both pumps? So this is work because those pumps are working. So we take work rate times time equals work done. So I have a large pump and I have a small pump. How long does it take them using both pumps? So I also have them working together. Large pump takes 50 hours, so the time is 50 hours. So how much do they get done in 1 hour? That would be 1/50th of the job. These two should always multiply together and equal one whole job done. The small pump took 80 hours. So what's the work rate of the small pump? 1/80th. How long for both? So together, I don't know how long. So the work rate would be 1/x. So right here becomes my equation. Large pump plus small pump equals together. Multiply by the LCD, which is 400. Excuse me, 400x. So this reduces out to be 8x plus 5x equals 400. 13x equals 400. Divide by 13. X is about 30.8 hours. Does it seem reasonable, but both pumps working together could get done in 30 hours? Yeah, that sounds really reasonable. You can spend the rest of the time working on your assignment. Tomorrow we'll do some more critical thinking and I'll show you how to do it on the computer.